Why is rocket mass fraction critical for payload gains? Imagine trying to carry a heavy backpack up a hill. The heavier the backpack, the harder it is to reach the top. Rockets face the same challenge with their payloads. The key to getting more useful cargo into space lies in understanding rocket mass fraction. This term describes how much of the rocket's initial weight is fuel versus everything else. The more fuel a rocket carries compared to its total weight, the higher its mass fraction. But it's not just about fuel. Rockets also need engines, structural parts, and, of course, the payload itself. To maximize payload capacity, engineers aim to keep the structure and engine weight as light as possible while packing in enough fuel. The reason this matters so much is because of a fundamental equation called the Tsiolkovsky rocket equation. It shows that the change in velocity a rocket can achieve depends on the exhaust velocity of the fuel and the ratio of the initial mass to the final mass after burning fuel. If a rocket has a high mass fraction, it means most of its weight is fuel, which allows it to reach higher speeds and go farther. This is essential for reaching orbit or traveling to distant planets. But if too much of the rocket's weight is taken up by heavy structures or engines, less space is left for payload. Most rockets designed for orbit carry only about 1 to 5% of their initial mass as payload. That tiny percentage highlights how critical mass fraction is. Improving it means making the rocket lighter or more efficient. For example, using lighter materials for the structure or more powerful engines that need less fuel can boost the payload fraction. Staging also plays a role. Dropping empty fuel tanks and engines during flight helps increase the amount of payload delivered. In practical terms, engineers focus on reducing the inert mass, things like structural parts and engines, while increasing propellant efficiency. They choose fuels with higher specific impulse, which means more thrust per unit of fuel. This way, they can carry more payload without building a bigger rocket. When the mass fraction is higher, the rocket can deliver larger or heavier payloads at a lower cost. This is why improving the rocket's mass fraction is such a key goal in space technology. It directly determines how much useful cargo can be sent into space, making missions more capable and cost-effective.